Okay, so here we're going to graph this rational function. And to graph rational functions, first of all, let's just, if this is not simplified, you want to simplify it. What I mean is cancel what's common in the numerator and denominator if it's not simplified. So assuming this is simplified, the first thing we want to do is set the denominator equal to 0 and solve. Well, when I add 3 to both sides, we get x equals 3. So this is where our vertical asymptote is. So at x equals 3, we draw our vertical asymptote line. Now the question is, all right, well, when x gets really big, we want to look at find the horizontal asymptotes. So when x gets really big, we covered this in an earlier video, when the degree in the denominator is larger than the degree in the numerator, the degree in the numerator is really 0, because we could think of this as 5x to the 0. The degree in the denominator is 1, because x to the 1 is x. So whenever the degree in the denominator is larger than the degree in the numerator, when we go to infinity, when x goes to infinity, this is going to go to 0. So therefore, all right, our horizontal asymptote is y equals 0. Again, y equals f of x. When x goes to infinity, this is going to go to 0. Our vertical asymptote is at 3. So we know when we go down this way and this way where our graph is going to approach the x-axis, y equals 0. The question is, does it come up like this? Does it do this? Does it do this? What happens? So now we got to look at what is, first of all, the numerator is positive. When the denominator, what happens in the denominator when we approach 3? This is 3, 2, 1, from the right. Well, we're like 4, 3.5, 3.1, 3.01 when we get closer. If we plug in 3.1 and subtract 3, we get positive 0.1. Yeah? So because these numbers are always bigger than 3, when we subtract this, we're always going to get a positive number that's getting close to 0. 5 divided by a really small positive number is a really big positive number, in other words, positive infinity. So as we approach from the right, this, our y value, goes to positive infinity. Up that way. As we already said, our horizontal asymptote is y equals 0. Y equals 0 is the x-axis, so this is going to get closer to the x-axis. What happens when we come in from the right, from the left? Well, when we come in from the left, these x values are always a little smaller than 3. And when I take a number that's a little smaller than 3 and subtract 3, the result is a negative. But it's a negative number getting close to 0. 5 divided by a small negative number is a big negative number. In other words, negative infinity. So as we approach 3 from the left, y goes to negative infinity. Similarly, our horizontal asymptote, similar to over here, our horizontal asymptote is y equals 0, which is the x-axis. So this is going to go like this. Where is this graph going to intersect the y-axis? Well, in other words, we're finding the y-intercepts. What is the value of x? Everywhere on the y-axis, x is 0. So to find out where our graph crosses the y-axis, we let x equal 0. And when x is 0, we get y equals 5 over 0 minus 3 is negative 3. This right here is going to be negative 5 over 3, or negative 1 2/3, or negative 1.666, whatever. But that's where it's going to cross there. So this is what the graph of this function is going to look like.